All right, number 11. The table above shows two lists of numbers. Which of the following is a true statement comparing list A and list B? All right. So look at the answer choices. They all compare the mean and the standard deviation. Okay, so mean is the average. Okay, so we can solve for the mean. That's actually easier to compare. So if we add up all the numbers, okay, and then divided by, so for list A, we have 6 numbers, so we can add them up. You do 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's actually 21 is the total. Okay, 21 is the total, and then we have 6 numbers, we can divide by 6. That should give us the average. Okay, it's a mean, which is 3.5. Okay, so for list B, we can do the same thing. 2 plus 3 plus 3 plus 4 plus 4 plus 5 is also 21. And then if we divide by 6, that's again gonna be the same, 3.5. Okay, so that means the mean here are the same because they actually have the same total. Okay, so the sum is the same, so the mean is gonna be the same. So it's not C and not D. Okay, so means are the same. But how about the standard deviation? How do they compare? Well, the standard deviation is on average, how much does a number deviate from the mean? Okay, so how much different are the numbers away from the mean? Okay, so pretty much if the numbers are further away from the mean, then we'll have a bigger standard deviation. And if all the numbers are closer together where the mean is, then we'll have a smaller standard deviation, right? So we know the mean is 3.5, so it's in the middle of 3 and 4. But if you look at the numbers here, right, the first number we have on the left side of 3.5, we have 1, 2, and 3. On the right, we have 4, 5, 6. And for set 2, the middle is still 3.5, but on the left side, we have 2, 3, 3, and 4, 4, 5. See, on list B is actually these numbers are a little bit closer to 3.5, right, compared to list A, because we have 2 here, right? And then it's closer, whereas so 2 and 5 closer to 3.5, compared to list A is 1 and 6 is actually a little bit further away. So list A should have a bigger standard deviation. Okay, you can also think of it like this. So standard deviation is a measure of spread. Okay, so how spread out the numbers are. If list A, you see we go from 1 to 6, so it's a little bit more spread out, okay, compared to list B. So list A should have a bigger standard deviation. So for this question, it doesn't matter which one has a bigger or smaller one. All we want to say is that standard deviation here had to be different. Okay, so it should be letter A for question 11. Okay, so pretty much unless all the numbers are exactly the same in two lists, so you can pretty much assume they're gonna have a different standard deviation. Okay, because we don't need to actually solve for the standard deviation, we just need to know here they will end up being different. Okay, because we have a different set of numbers here. Okay, and that should be it for this one.